All right, welcome to Mathematics Meal. This is a special edition of Mathematics Meal. We usually type breakfast question, just a meal that will make you healthy in the morning. We also have lunch questions and dinner questions. All right, today on breakfast question, the question is from the topic indices. And the aspect of indices that we are going to solve question from is on indicial equation. So let's go together on this breakfast question. We are given if 3 raised to the power 2x minus y is equal to 1 and 16 raised to the power x all upon 4 is equal to 8 raised to the power 3x minus y. Find x and y. Now, if you want to know about indices, all you need to do is to watch our videos on indices, starting from the introduction to the laws of indices and then simplification of indicial expressions and then equations involving indices. Do well to subscribe to our YouTube page. It's very, very important. All right, let's look at this particular question. How do we begin? Now, we have various indicial equations. This one is a case where the unknown is a power and we can express both sides in the same base. So in this case now we have two unknowns, and that's why they gave us two equations so that we can resolve them and form an ordinary simultaneous equation as the normal algebraic simultaneous equation in two variables. So let's look at this. We have 3 raised to the power 2x minus y is equal to 1. Okay, the first thing I need to do is to express both sides in the same word base. This already, the base here is 3, here 1. I need to make the bases to be the same. So that's what we call the common ancestors method. So I can write this as 3 raised to the power 0 because 3 raised to the power 0 is what? 1. So this will now become 2x minus y equals what? 0. Now when the bases are the same, means that the power are also the same. So if 3 raised to the power 2x minus y is equal to 3 raised to the power 0, the only way this can be possible is if the powers are also what? Equal. So we have this. We have resolved this. I can call this 1. Then I have this. 16 raised to the power x all upon 4 is equal to 8 raised to the power 3x minus y. Okay, now someone can say let's clear the fraction. Another person will say no, let's treat this as division and resolve both sides. Okay, let's treat this as division. We are going to have this as 16 raised to the power x divided by 4 is equal to 8 raised to the power 3x minus y. Okay, now all these, they have a common ancestor, and that is 2. That's the common base that we can express all these terms. And so 16 is something as 2 raised to the power 4, so I can write this, divided by 4 is something as 2 raised to the power 2, and then 8 is something as 2 raised to the power 3. 2 raised to the power 3. Let's create a space for this. Let's create a space for this. So we have that, okay. We have 16 raised to the power x divided by 4 is equal to 8 raised to the power 3x minus y. That's what we have. Okay, so this is something as saying 2 raised to the power 4 raised to the power x, because we have x here. 16 is 2 raised to the power 4. Then this is 2 raised to the power 2. Now 8 is 2 raised to the power 3. Now we have a power already, which is 3x minus y. That's what we have. So I can write this as 2 raised to the power 4x divided by 2 raised to the power 2 equals 2 raised to the power 9x minus 3y when you open this bracket. So all we are trying to do is to express both sides in the same base if we want to solve this equation now. So we have this. So we are going to resolve this again using the second law of indices. A raised to the power m divided by a raised to the power n is something as a raised to the power m minus n. That's the second law of indices. Applying it here will give us 2 raised to the power 4x minus 2 is equal to 2 raised to the power 9x minus 3y. Okay, so we're almost through. Just gradually we'll be through. Now the bases are the same, so we have 4x minus what 2 is equal to 9x minus 3y. So if the bases are the same, equate the powers, because the powers will also be the same for two equal indicial terms. Alright, so we can now, this ordinary equation, now we can solve that by having 4x, resolving this, minus 9x plus 3y equals 2. I brought all the terms that have letters here, while this ordinary number, taking it to the other side. The sign is negative, moving here becomes positive. Now 9 moving here is minus 9x, then minus 3y coming over here becomes minus 3y, plus 3y. So we have now 4x minus, this is minus 5x plus 3y equals 2. So we have two equations now. One is 2x minus y is equal to 0. The other one is minus 5x plus 3y is equal to 2. Okay, there are so many methods of solving simultaneous equation. We can use the elimination method, substitution method. We have Cramer's rule, that's the one you use when you have the matrix, the Cramer's rule from matrix, using the principle of determinant. We also have what we call equal variable method. I'm not going to use that equal variable method. Let's use substitution method here now. So this is equation 1, that's equation 2. Now from equation 1, we have that 2x minus y is equal to 0. That means if I make y the subject, 2x will give me 0 plus y. So 2x is what? Y. So what it means is that y is equal to 2x from equation 1. So let me substitute it in equation 2. Substitute the value of y from 1 to what? To equation 2. So if I do that, I'm going to have here minus 5x plus 3 times 2x. Why? Because y is what? 2x equals 2. So minus 5x plus 6x is equal to 2. Then this will give me x equals what? 2. Since I've found my x to be 2, I can easily find what? Y. How? Y is equal to 2x. So y becomes 2 times 2. Y will give us what? 4. And that settles it. Y is equal to 4. So in this equation, y is equal to 4, x is equal to 2. You can check it here. If x is 2, 2 times 2, 4, and y is 4. So if I have this 3 raised to the power 2x minus y, and x is 2, y is 4, this will be 2 times 2 minus 4, 4 minus 4, 3 raised to the power 0, and 3 raised to the power 0 will give me what? Will give me 1. So if you test it again here, we're going to have 8 raised to the power 3x minus y on that side. 4, 2 times this is 6, I have 8, 3 times 2 minus 4. That will give me at the end of the day, 3 times this is 6. 6 minus 4 will give us 2. So I have 8 raised to the power 2, which will give us what? 64. Now if x is 2, I have 16 raised to the power 2 all upon 4. 16 raised to the power 2 is 256. If you divide it by 4, you also have 64. That's all for our breakfast question today. Watch out for another breakfast question another time. Continue to enjoy Mathematics Mail, and make sure, please, that you subscribe to our YouTube channel. Share this video to as many people as you can. Thank you, and God bless you.